Good afternoon, everyone. I will hope you all had a tasty lunch. Now it's time to relax and maybe take a nap. I hope you don't. I might wake you up. No, I got some exciting stuff, I think, to tell you about Gradle. Latest things that are happening, that have happened, that will happen. So I think it will be good to stay awake. Hans Doctor, who was initially meant to give the talk, the CEO and founder, cannot be here, has some very important meetings in San Francisco. So he asked me to speak on his behalf, which I'm of course happy to do. I gave a presentation on Gradle and Android yesterday, and today's the focus is just a bit broader. So with that said, just for those that know a bit of the history of Gradle, so the company, the name has basically changed. It's not Gradleware anymore, it's just Gradle, right? Which makes a big difference, surprisingly. There's a new Twitter handle. It's just Gradle, not Gradleware anymore. That was hard to guess. And we also have a new domain. We don't only have Gradle.org, we also have Gradle.com now. But you still find everything on Gradle.org. There's also a new brand, which is Build Happiness, with a pretty heavy elephant. But don't underestimate the elephant. He might be heavy, but he's still fast. He's still determined and smart. And just to, as an introduction a bit, what do we mean by build happiness? What do we want to we want to end code freezes, no more bug regressions. You can see he's angry because he doesn't like chaos. He doesn't like death marches that some of us have already done. He doesn't like long build times. And broken release process, which nobody of us has, right? Gradle is basically in 3 domains at home. Android is the first one. Java is the second one. And C++. It doesn't mean you cannot use it for anything else. Of course, you can do Kotlin, Scala, whatnot. But these are kind of right now the 3 pillars with a lot of traction and a lot of investment and a lot of output as well. If we look at downloads, in 2014 there was like a total of 5 million downloads, which is a pretty respectable number. But alone in May we had like 800,000 last year, and since October it's more than 1 million every year. And the thing to keep in mind is that Android Studio now uses the wrapper, which means those downloads that come through the wrapper are not included in those numbers. So the actual people downloading or machines downloading is even higher. First, I'd like to ask a question. Who's running some Gradle builds? Okay, I would say maybe 70% or so at a glance. And who has actually touched some Gradle scripts? Oh, okay, that's probably almost the same number. Nice. Build infrastructure has become very central in today's software delivery process. It's super important, and I would say it's kind of the backbone of successful software delivery. And this ugly picture, Hans always uses it, so I kind of reused it, which is about many projects have a very broken build process, but they just live with that pain. It's like, oh, I can still see with one eye, I still have one nostril to breathe, so things could be worse. And the thing is, things will get worse. Yes, why will they get worse? Software projects get bigger and bigger, unless you have a project that gets smaller over time. But I don't know many of those. So projects grow. Let's say by 20% a year. After 4 years, you have doubled your code size. Probably on top of that, you will also have more people on your team because you have a much bigger code base to take care of. Right? So you now have a bigger code base, you have more people, and you have this broken build. You're gonna blow up, right? So it is really important to have a grip on your build and the whole delivery process to production. The other aspect is complexity. Our domain is getting more and more complex, and I think Android is a good example. You have different platforms, you have different devices, you have native code, you have kind of Java code. you have to generate resources, sources, and so on. So lots of complexity is in the domain. And it goes beyond that. You don't just do Android or native. Well, you will also have maybe some Java code and some Scala code and some front-end code, and that comes with their own tooling. And so to embrace all that and have like a polyglot build is really important, because otherwise you have all these pieces, but then at some point you need to put them together, and you don't want to spend months putting them together. You want to have this feedback basically constantly, no matter what part you change. And to give you a concrete example, in 2011, LinkedIn, which is a big Gradle user, before they were on Gradle, it took them like 30 days to do a release, which means about like 15 days development, 15 days of releasing. Right. And they have an excellent software development team, right? So in 2013, when they did over the years, basically they did a lot of improvement to their builds. They switched to Gradle. It's highly automated. They are now at 2 releases a day. And there's also an article in Wired that explains or kind of suggests that a high impact was from the build system to get to that productivity in measured by releases a day. Right. To give you a few more numbers, because I can share them, LinkedIn has like about 2,000 developers working with Gradle. Doesn't mean that they have 2,000 developers in total. It will be more. Oh, sorry, you don't even see that yet. Sorry. And those developers create about 2,000 software components, or have to maintain those 2,000 software components. And they do about 300,000 executions per week. Right, so that's quite a few. And they do 1,000 releases. Okay, so they put those components in a releasable state. Right? And those numbers are not possible, maybe except having 2,000 developers, if you don't have a build infrastructure that allows this kind of automation. So with that said, let's look at performance. Performance from a perspective of the CI, so your continuous integration, but also from the perspective of the developer. And I assume everybody cares about performance. Right? Everybody wants a faster build. Nobody complains, says my build is too fast. So this can always be better. So what is our goal? Our goal is to minimize the build time, and we want to do this with as little memory as possible. Right? Now, what we can observe in our build when it comes to performance is that typically not much changes between 2 invocations. You just change some source code, maybe some resources, a little change here and there. But that's it. You don't change the whole build between 2 invocations typically. Right? And when little changes, only little work should be done. Right? And I'm going to come back to that again throughout my talk. And so there should be a relation that should make sense. If you make a little change, there should be a little impact on how much work needs to be done. So what's the approach that Gradle is taking to performance? We have 2 kind of things going on in parallel. One is just evolutionary improvements, right? You can do a lot, and I'm going to show you a few. The other one is revolutionary changes. To say, okay, we're not going to micro-optimize, we're going to go for the global maximum, basically. So what we do is, if you kind of very generally look at it, is we can fix hotspots. That's more of the evolutionary changes. We can do more caching, more reusing, which means less recalculating things we already know. We can do things in parallel, and we can do stuff in the background. And all these things, very high-level items, you can do them to different things. You can do them to the configuration phase, you can do them to the execution phase, and you can do them to dependency resolution. And we've already done quite a few things to the execution phase, but there's a lot more we can do to the configuration phase as well as to dependency resolution. Okay, so maybe keep that in mind a bit as I show you some stuff. Because basically everything I show you will fall in one of these categories. The daemon. Who's using the daemon? Okay, not too many hands. That's a pity. What is the daemon? The daemon is kind of a reusable background process to execute your builds, which means it's running in the background and it's just waiting for work. And the moment you run the build, it's being passed to that process and it will run the build. One thing very powerful about it is if you rerun a build with the same configuration, like the same class path, etc., that process will be reused. Right? So which means no new process needs to be started, and the JVM is already warm from a previous run. Okay. By default, it's not enabled, but it will be enabled soon, and that's exactly why there are not too many hands raised, is because you have to explicitly enable it. But it's super, as a developer, it's super safe to do. Right? There's no reason not to do it. The only reason it's not enabled by default because there are some issues on Windows, which on CI could have an effect that you don't want to have, but that's being addressed. So I can highly recommend to enable the daemon. You will see it's much faster. How do you enable it? Just for those that are really interested in doing it, you can go and do it in the Gradle properties file of your in your own home directory on the Gradle properties, or on the .gradle. You can do it as a Gradle option that you pass in, or on the command line you have a flag to say use the daemon. Right? And what you will see is, if you look at your activity monitor or so, is there's a new process or a new Java process which is your daemon that's running. Those daemons are recycled and etc. But that's all taken care of. Right. Okay, so that's one, and that falls into the category of reuse and caching, right? Because the daemon itself is not just a process, it just takes what comes and we can reuse the JVM. It can also reuse cache stuff, right? So if you don't have that daemon, a lot of things we can cache, well, is not cached between runs because it's not persistently cached. Incremental build. I'm sure you all noticed this when you run your build. Twice in a row, the second time it doesn't do anything unless you have custom tasks that don't have their inputs and outputs properly defined. So this is very central. If nothing changes, you don't want to do anything. So if you look at the task, it's like a function. It has an input and it produces an output. Inputs are usually files and outputs are usually files as well. But it could be a system property as well, or some other property that you feed in, into the task. So that is really important, that if you want to have a fast build and nothing changes, nothing should be done. So if your inputs are the same and what the task produces is the same, nothing has changed, well, let's skip that task. That's what you're going to see as up to date in your command line output, for example. And it's not based on timestamps, purely on timestamps. It's based on the timestamp as well as the file size, and like modification time of the file size, as well as a hash over the content. Right, and then there's some smart logic in there to do the optimum, to be as fast as possible to detect if something has changed or not. Right, there's no need to create the hash for the file to look if it has changed since the last run. If you already know the timestamp is different and the size is different, then you already know there is a change. Right, so there's some optimizations in place. There are also some optimizations related to what JDK you're running on, but it's all hidden for you. So we have done a lot there over the past few releases to make that even faster, because you have some companies like Unity, they have like 500,000 source files, the gaming company. So for them, doing these up-to-date checks can be really expensive, right? And just to learn in the end, nothing has changed. Right? If something has changed, okay, then you need to do work anyway, and then it's not making a difference. But if nothing has changed, you want to know that as quickly as possible. Okay, so a lot has happened there and is continuing to happen. The next thing is continuous mode. Who has used the continuous mode? Yeah, even less hands. Yeah, that's, again, is a pity. So the daemon you can enable and safely. Continuous mode is a very nice feature too. And it is based on what I just showed you with these incremental runs. And it is about, I'll show you on the next screen. I wanted to give a demo, but I think I'm going to skip it because I'm too scared that it's going to screw up the whole setup here with all these things being plugged in there. So basically, you run a build like usual, but you run it with -t. And what -t says, run it in continuous mode. And if you do that, Gradle will run your build, but when it's done, it's not kind of coming back to the command line. It's kind of waiting, right? Waiting for changes. And now what happens is, it knows all the tasks that are depending on the build task. And if any of those tasks, or the build task itself, if those inputs change, then it will trigger a rerun, right? So that concept of inputs is now being reused. So I can make a change to source file, Gradle sees, oh, input of the compile task has changed. Let me run that task again. Right. And of course, if other tasks depend on that task, they will also run if the input of them has changed. Right. So super powerful. Why is it so powerful? Because the JVM comes up and it keeps running. Right. So as you make changes, the JVM is already warm and it stays warm. Right. And it works very, very reliably. And what's also great about it, just recent change that was made, is even while the build's running, you can make a change and Gradle will detect it, and as soon as the build has finished, it will trigger a new one right away. Cool. It's a bit like there was a time where people said, oh, you should have your tests and they should always run, and you just change your code and the test should always run. And if the test doesn't pass within like 30 seconds, the test should delete your productive code or something. I mean, that was a bit extreme. Gradle doesn't do that. But at least the idea of constantly picking up the changes, running them, you can achieve with a continuous build. So just dash T, and that's all you have to do. Right? Or if you do web application development, that could be a good option as well. Another one is project substitution. So let's say you have a big project, and now you always depend on some other projects, but you know they don't change or you don't really work with them. So basically you could just use whatever they produce, their artifact that was published, and just use that when you run the other project. And that is possible, and it's possible the other way around as well. So it's called, there are substitution rules. And what you can do here is you can say, the second line basically is what I just mentioned. So you can say, if I have project impl, that in my service I have project services, and or API depends on impl, you can say, well, instead of always running the task that create me the artifact impl, just use the artifact in that version. Right. And the other way around is possible too. You can say, oh, instead of using that external dependency called org-utils API, well, I want to use it from my project. Right. So let's say you want to debug a library that you're using and you have it locally set up. Instead of using that maybe buggy version that you're using as an external dependency, you can use the local version that you have with source code, and you can make changes and see how they affect your outcome. Okay, so that's a very powerful feature to use. And we'll see something similar soon about later in this presentation about composite builds, where the same is applied not within a multi-project build, but across multi-project builds. Android Studio. So there have been a lot of performance improvements in Android Studio 2 compared to 1.5. And I still want to mention them, even if you don't do Android development, because they are generally applicable to some extent. So what we see here is Android Studio. The green one is Android Studio 2.0. It's not final yet, but it will be within a few weeks. And the other one is 1.5 or 1.3, doesn't matter, the numbers are about the same. And what you can see is the dexing got really fast. Dexing is a process of taking your libraries and converting them, or taking your Java code and converting it. Now let's look at the third column. That's what I want to show you. Also, the install time got way down, or I should say, it will get way down once Cold Swap and Emulator 2 are going to be ready or final. Why am I showing you this? Because this is very Android specific. The reason is that what you can see here, as dexing comes down and the install time comes down due to changes in Android, suddenly the other stuff there under other becomes much more relevant, and in that other category is where Gradle is. Right? So suddenly these Gradle improvements have a big impact on Android builds, while before they were kind of lost in the noise of big dexing time. Okay, so let me show you this here. You can see that the green bar is with the improvements that we have in 2.9 and 2.11 that came out the beginning of this week. It's even more. If we didn't have those in those Android builds, the overall time would be 30% higher to run those sample or reference projects that we have. Okay. So that's the good thing. You make an improvement in Gradle, maybe targeted towards Android, but other builds will benefit as well. You make it for C++, usually somebody doing Java benefits as well, because it's conceptually an improvement and not just very specifically solved for one platform. Okay, let's look at the new configuration model. That is something that has been working on for a while, and that is intended to come soon. It's already experimental. The Android plugin experimental version of it is also already making use of it. The C++ plugin is making use of it. The new Java software model, yes, is making use of it as well. So it is real, it's just not finished. And the idea is to apply the same concepts that you know from the execution phase, you know, those inputs and outputs and skipping stuff, to also apply them to the configuration phase. Okay. And in order to do this, the configuration phase has to be, what you configure has to be much less imperative, right? If you can just do whatever you want to in your build scripts, Gradle has no clue what you're doing, and they cannot reason about it, they cannot optimize it. It can do with tasks because it knows the task graph and it knows the dependencies between the tasks. So it can do all smart optimizations. And we want to get there with the configuration phase as well. So let me give you some examples here. So at the heart kind of these managed types, which you define in terms of interfaces, which means Gradle provides the implementation, which means Gradle controls the implementation and knows what's going on. It knows who calls this, which means it can kind of build up a tree of all those dependencies between those managed type nodes. And in the end, you end up with 3 again. And then you can do the same optimizations or similar optimizations like you know from the execution phase. Plugin. The way a plugin is going to look in the future for those kinds of configurations is going to be in terms of a rule source, which is just a collection of rules. So you have 2 rules here, one that creates a managed type and the other one that mutates it. There are other kind of annotations, what you can do with them, but basically there's almost like a life cycle to each managed type, and it makes it much more easy to extend it, to modify it, and to know what's going on. Especially when something doesn't go as you expect it to go, you will quickly understand what's happening. If you have a small build, this is not maybe a key issue, but if you have a huge build, it becomes quickly the question, who modified that last, or who even modified that, right? Where is that value coming from? There will also be a DSL, so the same thing I just showed you in code will be in the DSL, and that's probably more interesting for those of you that just write build scripts but not plugins, is how do you configure such a build? And that is, I mean, it's not final, but it's more or less, or it's how it could look like, or how it's currently looking like. Aspect, as I mentioned, is the reporting. It will be much richer in terms of reporting, because Gradle will know where these things are configured, who's accessing them, who's modifying them, and then it can do nice reports in the good case, but also in the failure case. So to summarize that modeling aspect, and I'm going to come to performance, why I mentioned this in the context of performance in a second, is you're going to have richer modeling, you're going to have a cleaner modeling too, and you're going to have collaborative modeling, meaning if you provide some models, another plugin can come and further modify those plugins, and it will be in a controlled way and not just like a sync all at the end where you hope you're the last so nobody overrides what you just did. And comprehensive modeling, like I just showed you, the report is one manifestation of that. If you look at performance, so it's not just nicer modeling, it's also performance. And here, the key is, if you look at the light blue bar, it's almost the same, no matter, this is an Android project, but doesn't really matter, you can have Java projects with variants as well now. It doesn't really matter if it's it doesn't really matter if you just build one variant, one project, or the whole build. It takes about the same time. And that's not what we want, right? The less work that should be done, the less it actually should do. If only one variant changed, it shouldn't do the whole build. And that's what you see with the blue bars. That's with the managed types. So that's using the new model. Only one variant changed, or something that affected one variant, only little work had to be done. If everything needs to be built, it's still faster, but really the key is the difference between build all and build one variant. That is going to make I think a lot of Android developers very happy, because even if you say Gradle tasks, in the Android case, a lot of configuration has to happen. But it's not really restricted to Android builds. Okay. So the other aspect I would like to cover is modeling. So we have looked at performance, how we can evolutionarily improve it and revolutionarily improve it. But another aspect that's really important is how do you model your software? Because that is getting more complex too, right? We have now microservices, we have Jigsaw coming, and so we need to somehow express this, and that's something at the heart of Gradle from the beginning, is that you want to model the domain, because if you model it, you can reason about it. So the first thing I would like to show you is the JVM software model that is currently worked at. There will be a blog post very soon about it too, kind of introducing it, how it's working, what's already working, what's coming. So this is super exciting, I find. And I'm going to give you 2 slides with code here. So the first is a service. So here it's meant the service does something for you, and then somebody else can consume that service, right? And you don't need to kind of understand every line of code here, but basically what you define at the very top is a component, and you say that component is called a service. Could be called anything, right? And then we say, well, what makes up that component? The component is made up of some sources, and it has some dependencies. You can also see that the first dependency is a library that is exported, which means that whoever consumes it will also see that exported library. Though having done OSGI, might know the concept. And then the second aspect is we are also defining an API, right? Which means this is what we are exporting, right? Whether it's called API or something else is again is up to you. The key is we are exporting a package. Okay. And then we also define 2 target platforms, which means when we build this service, we want to build it for 2 platforms. We want to build it for Java 7, and we want to build it for Java 8. Okay, we build a service. It's going to be, in the end, it's going to be a library, a jar file. We export one of its packages, and we want to do this for 2 target platforms, 7 and 8. Now let's look at the client. The client is again a component. This time it says, or it's named client. And it also has some sources, and it has a dependency. And it has a dependency on a project called service. Right? And of that project, it wants to use the library called service, which is what we just looked at. The library is called service. Right? And then we can say, for what platforms do we want to build the client? Right? And so now what that means is the client will only have access to those packages that have been exposed by the client. And there will be some performance implications by that, but I'm going to come back to in a second. Right. The other thing is about the target platform, because now we're getting variants for Java as well. We already have them for C++, and we have them for Android, though Android with the old plugin has to do it kind of handish. But now it becomes a fundamental principle in Gradle core. So these are all going to be variants for the different platforms. And what you can imagine is that if you're building the client for Java 7, it should also use the Java 7 service, right? If you're Java 8, it should use the Java 8 service. Now, what's happening with Java 6? There is no Java 6 on the service that was defined, right? So that could be a problem. And there's also another Java 9. So there are some rules what to do when the versions don't match, your variants don't match. Okay. So that is an example of the new Java software model. What will come here is also to have dependencies that are specific to a variant. So you could say, if I'm on Java 6, I need some retro library, but I don't need it for Java 7. Right now you can't do that, but that's kind of coming very soon. So what is the performance impact of this, or the benefit of this? If you have a project that depends on this service, and now you make a change in the service, in the implementation, that's not even exported, well, you don't need to recompile the client, right? Because he's not affected by that change. And so on. You could even go further. You could say, well, the public API did not change. Even if it's an exported package, if something in there is changed that is not part of what the other side can consume, the client, then there's no need to recompile neither. Right? As I said, this is already available for C++. The same kind of, so you can see you always model components. In this case, it's platforms, it's build types. You can have cross products of them. And then you define components where you say, you always say what you want to build and what you want to, where's your target, etc. Right? So it's different to the previous approach where it's always task-based. Tasks are not at the center anymore. Tasks are kind of the outcome of defining those components. So it's much stronger model. You're modeling what you want to end up with in the end, or what you want to have in the end, and Gradle will figure out what needs to be done to get there. Variant-aware dependency management, as I mentioned, that's going to be is an outcome of that as well. So each platform is a variant. On the C++ platform, you have different processor architectures that are part of your variants. Okay. The next thing to show is a continuation basically of that software model work, which is compiler avoidance. And I'm going to show you a little movie on that. So here it is about, it goes towards Jigsaw, where you say, I define my projects and what they export and what the other ones consume. And only if that public API changes, we do need to act on the other side. So it's very, very close to what I just showed you for the software model. So let's assume we have the following project set up. It's a multi-project build. Each project has 1,000 source files. And you see how they depend on each other. So 15 depends on 14, etc. to 2 to 1. Right. And what we're going to do is we're going to do some changes in 1. And we want to see how much work has to be done. Right now, if you do make a change in 1, it's pretty much affecting every project. Because if you have a different bytecode, and the other projects depend on that binary that's created with this bytecode in it, they have to be at least recompiled. Right. Okay. So let's watch a little movie. So what happens here is calling assemble on project 15. So this is the one that depends on all the other stuff. And you can see it hasn't been built before. So all those projects build 15, 14, down to 2 and 1. It doesn't build those projects on the side we had, 7, 8, 9 or something. Right. And now we go in. And we can see here that it only depends on performance. Performance 1.1 is what it exports. Right. That's the thing to keep in mind. And it also uses a library that is not exported. Right. So now let's compile again, or assemble again. We haven't changed anything. We're just running it again. Everything's up to date. That's our incremental build, right? That's not new. We expect that. Okay, now let's go in. And let's go in another package. Let's not go in 1.1. We're going into another package. Make a change. Right, you see it depends on, it exports 1.1, but we're making a change in 1.2. Okay. Right, we're changing an API, right, of this 1.2, but it's not exported. Now it runs again. And what you can see is project 1, yes, had to build because it had source files changed, so it had to recompile. But project 2 did not have to recompile, right? Okay, because it was not affected by the change because the change was not something that was exposed to that project. Now we go into the performance 1.1, so that's the one that 15 depends on indirectly. And we change something that is exported. And we didn't change an API, we just changed the implementation. Right. So you can always ask yourself, what should it do? You can see it only compiled 1, but not 2. Because, again, the public API that is exposed didn't change. The implementation of something that was exported changed, but not the public API. So we don't need to compile what compiles against it. Now we made a change to the public API. Right, and now you can see 1 as well as 2 are recompiled. Okay. But then, since 2 did not expose that, the follow-up projects did not have to be recompiled. So we don't have this full chain happening every time we make a change. Now, next change is a change to the library version. Library is not exported. Right, only 1 was compiling. Okay. Again, because that library was not exported, so the dependent project doesn't care about that. Right. Does that make sense? Cool. Okay. I mean, the concept is not new, but to have it available in your build and with in a way that you can model it is pretty nice, especially when you have a big project and you have something you change. You don't want to have those changes percolate downstream if not necessary. Right. Okay. Third aspect I wanted to cover, besides performance and modeling, is company standards. And so there's some stuff in here from what we know that other companies do, some things we would do, yeah, without really associating two names, but it doesn't really matter. And you can think that certain problems you might only have with a very big setup of thousands of developers, but others you can as well apply to a small project. What is crucial about it is company standards, especially when you have a lot of maintenance you have to do. You want to be on top of that, and you have a growing team. If you don't have standards, that's gonna eventually it's gonna blow up. Okay, so what some people do, or some companies, is have high-level DSL. Right, so Gradle comes with its DSL, but if you want to make it really easy for your developers to just start a new project, and because it's always the same kind of project, just another kind of flavor of it, you want to give them a really nice DSL, and underneath you do all the work for them. You create all the tasks, you wire them up as necessary, and they're good to go. If you're a build master, of course. So just to give you one very, very simple and fake example, but let's say you do a lot of products, and each time a new project starts, you want to create a new product, you have to do certain work. Where do you want to deploy it to once it goes to production? So you could create your own DSL that looks like this, where you say, okay, products, you can define your own product name, which would be called foo in this case. There's a quote missing after foo, but doesn't matter. And you could say, okay, when we deploy for European customers, the host is alpha, whatever it's called, doesn't matter, which means it will then go there and there, which creates separate tasks, which maybe creates a whole different pipeline, who knows. And if it goes to Asia, it goes to a different host, which has, again, a totally different pipeline. So all these things you can hide behind the high-level DSL, and you take care of the implementation through plugins. Right. So bigger companies do that a lot, just to standardize on how people do certain things, because you don't want to reinvent the wheel of how you wire your delivery pipeline for every new project that comes up. Maybe a new project comes up every day. Maybe an insurance that comes up with new product ideas every week. You need to be quick. You want to give them a high-level DSL so they can quickly focus on the content, and the build takes care of the rest. And also, if you change the implementation, the DSL hopefully doesn't change. So not every project has to make some changes to it, but only the implementation in your plugins. Dependency management. Certain companies will not allow you to use alpha versions or beta versions, or a certain version is not good, so you should not use it, and so on. And you can have some certain standards. And again, I'd like to show you a little demo on this. So basically here we have two dependencies. One is JSON token, the other one is wiremock. One has a dependency on Google Collections, which is really old. The other one has one on Google Guava, but it provides the same implementation. And what you can see is if we just look at the dependencies of the compile configuration, you can see here on the top, Google Collections is up there. And you can see further down, Guava, which comes in from WireMock, right? So that is how that is our starting position. Now, we don't want to use both versions, right? We just want to have one on the class path. So what we can do is, we can go back into our file and we can say, if you have a conflict, if you have Google Collections, use the Guava one. And if we now look, you can see up there, instead of Collections, it has a little arrow saying, well, instead of this, I'm going to use Guava. Okay. So that is one way to standardize and say, okay, if we have these different libraries, well, we always want to use this one. That's one way to do it. Okay. Interestingly, if you remove one of those dependencies, there's no more conflict, in which case it will just use the dependencies that this JSON token wants to use, right? So only if there's a conflict will it make a decision. If there's no conflict, in that case here, you're able to use the version, or the version that we used that was coming from that dependency.
I have a question. Yeah, how is that different from the example you showed in the beginning with the configuration, the other substitute configuration, where you substitute one?
Yes, this applies only to conflicts. Conflicts are very, very oftentimes occurring if you have a big project with a lot of dependencies, and those dependencies have transitive dependencies. And what I showed you here is only to resolve those conflicts. You can have strategies to say what to do when you have a conflict. What I showed you before is not related to a conflict. It's just saying if that version or that library is on my path, I want to replace it with a project dependency. So it's a different kind of substitution. Yeah. Okay. Well, there's another one. I'm not going to do it. The movie just show you briefly. Here you can see you can also reject, for example, 513 final because you know there's a bug, or for whatever reason you don't want to use it. Right. The other one is to say any component that has alpha or beta in it, we don't want to use that. And that also works with dynamic versions. Right. So if you have dynamic versions, it might say, oh, 513 final is the newest one. But then, no, rejected. Okay, what's the next new one? 512 final. Okay, let me use that one. Okay. Some people argue or often say, well, Gradle, you can do whatever you want to. We want to use Maven. There we have all these strictness. You can be very strict in Gradle. You can be much stricter, and you can be much smarter about how you are strict. And I would like to give you just one example. Because there is such a deep modeling behind it, you can get to all this information and make a decision based on that information that you have available. So, just one example here. Let's say if it's an Android project and you find an Android extension and you have a build type that is release, you want to be sure that ProGuard is enabled. If not, that takes care of the obfuscation. If not, you want to fail the build. Right? You can have that in any script. I'm going to show you how you can share it with the whole company. And then it means there will never be a release build or release type build for this Android project that doesn't have ProGuard enabled. Right? So these kind of policies are very easy to put in place. Or you want to measure how long the test execution took. If any test takes longer than 20 seconds, throw an exception. You can do all these things. So having kind of policies in place, if you want to, is very doable and very powerful. What some companies do beyond these things I just showed is to have like a custom Gradle distribution. So let's say you want to have those policies and you want to put them in some scripts, but you don't want every project to apply those scripts again. And what if they don't apply them, they don't get the policies, right? That wouldn't make sense. So what they tend to do is they take a standard Gradle distribution, you add your own scripts to it in a certain location, make a new distribution with it, and then in your project you just point to it with the wrapper. Right? So when the person checks it out for the first time, Gradle build, the wrapper will point to that custom version that you host somewhere on your servers. It will use it. It will apply those scripts that you have in there, if they're init scripts. Well, it will automatically apply them, and if you apply some plugins, some hooks that make those checks, like I just showed you one, everyone that builds will have those checks available, right? So that is a quite common scenario for that as well. So basically all you have to do is in the distribution, you put them in that folder, make a new distribution, point a wrapper to it, and you're done. Some companies go even further, they wrap Gradle. So people don't even know they're using Gradle. But underneath the tool or the abstraction they give, the users will invoke Gradle. And when they're on CI, they will directly call Gradle. And Gradle itself will then coordinate all the tool chain, etc. underneath. That's pretty extreme, I would say, but that's what other people do, or some companies do. There's also IDE integration, which is really important for most companies, so they don't want even people go to the command line, they just want people to check out the project and go with it. So we've done a reference implementation or I would say the official implementation for Eclipse BuildShip. Yeah, and what that gives you is, or what we try to do there is have all the build logic in your build. Such all you do is import the project and you're set, right? If you're using a plugin that makes you then click all these buttons and checkboxes to have a running setup, that's not the idea, right? The build logic should just be in the build, and we achieve this with this plugin and the Gradle build on the backend. What's coming soon is custom build environments, so really to almost bootstrap your Gradle setup beyond just pointing the wrapper, saying which Java platform, what plugins should be automatically applied, etc. Composite builds is also something that companies want, especially big companies, because they have multiple multi-project builds and they depend on each other. And when they import all those projects into an IDE, like Eclipse or BuildShip with the plugin, they don't want to have all these projects open even though they only work on one. So there they want to have project substitution like I showed you before, but across projects, right? And we're working on that currently as well. And I could give you just a very short demo. I think we can afford that. So what we do here is we do an import of one project, project 2. We open it. And you can see it has a dependency on project 1 as an artifact. You can see it there using a graph to say what the dependency is. And now we import project 1, which publishes exactly that version of that library. And if we now import that, you can still see it's still depending on that, but now we do a refresh. Right now we do it manually, the refresh. You can see now it depends on that project. Right? So the moment you imported that other multi-project build, you were able to say, well, now I don't want to use the binary anymore, now I want to use the project. Right? And that is huge if you have a big project with 500, 600 modules, which seems to be very common. Okay. What's coming soon? Besides all this work that's already going on, there's only one more thing I wanted to mention in this context, and that's distributed cache. So all the caching that's already happening, and with the daemon, if you all use it, you will get benefit from that caching as well. There will also be some distributed caching, which will allow you to, also when you do things like transformation of dependencies, to do that once in your whole environment, and everybody can locally benefit from it. Right? So there's a lot going on there as well, or coming, I should say. Then we're also building a product, like an online build collaboration tool. And that's what I currently work on, that it will allow you to share what happened in your build online through visualization of what happened in your build. Right? And you can then look into problems. Like you have a problem, you had a problem with a dependency that yesterday worked, today not. What's going on? You can point a link to your build master, he can look at it, and he can help you. So very exciting. That's kind of in progress, and it will soon be kind of launched. If you want to become a Gradle expert, unless you already one, there's also this class from Udacity. Right? It's about Android, about Java, but also about Gradle. So it's a great class to get more details. There's also some online training. that you can do, so just a few hours or a whole day or so, that I can really recommend. And the last one, it would be great to see some of you at the Gradle Summit, in case you, it's all about Gradle there, right? And they have t-shirts as well. That's a long way to get there. So with that said, thank you for your attention. I hope you could see that there's a lot of excitement or exciting stuff going on to make Gradle faster, better modeling, and to have those standards in your company. And that is going to go on for a long time. So much more is coming. Thank you.